So today we're still in chapter 7. We are today going to be talking about exponential growth, exponential decay. We are also going to be talking about compound interest, which is on the backside. But we're going to start with exponential growth. So each of these problems has a formula that we will be going to. These are sort of plug and chug problems, meaning that you're going to have a formula, you're going to take information, plug it into the formula, and then you chug things out on a calculator and get your answer, right? So, our formula for exponential growth is as follows. We have f of t, come on, let's try that again. F of t equal to a times 1 plus r raised to the power of t. Right? So each of those letters, of course, has a meaning. There is a value associated with those. And so if we take a look at A represents the initial amount. If I have growth, then I'm starting with something. And whatever that starting value is, the initial amount is what A represents. R, yeah?
Wait, so is the starting value and initial amount the same thing?
Mm-hmm. Yep, the value that I'm starting with, or initial. That's what initial means. Initial means in the beginning, or the starting, right? So then R represents the growth rate. The growth rate. And then T represents time. Okay, so when we work these problems, basically you're going to be plugging information into this formula sort of over and over again, dealing with different situations. So let's play with this first one. We have an investment that has an initial value of $1,800. If the value has increased by 7% each year, then they want us to write an exponential function to model that situation. Then they want us to find the value of the investment after 15 years. So we're being asked to do two things. One, write an equation. Two, find a value after we've written the equation. So, when I work these problems, I prefer to start by defining what it is that I know. So, for example, in this problem, A is what? What is A in this problem? Yeah. 1,800 or 1,800. And then my R is, yes, 7%. Now, 7% is not a number. It's not something I can plug into equations, right? So I can't use 7%. I have to use 0.07, right? So I take my percent and I change it from a percent to a number. And when I do that, in this case, I get 0.07. Okay? So those are the two values that we're going to start to play with. I like to write my equation down again, just so that I am very crystal clear on what it is that I am substituting into. So I'm going to recopy my problem, right? F of t is equal to a times 1 plus r raised to the power of t. And so we wind up with, sorry about that, let's fix that and try that again. So we wind up with f of t equal to 1,800 times 1 plus 0.07 raised to the power of t. All right? So what is 1 plus 0.07? What do I get when I do that math? Yep. Cooper.
1.37.
Yep. So my final equation then is f of t is equal to 1800 times 1 and 7/100 raised to the power of t. Yes?
Okay, so if T stands for time, wouldn't that time be 15 years?
Yes, but they're asking me two different things, right? So one of the things that they're asking me in this problem is to write an exponential function. So in writing an exponential function, I am leaving t open for change, right? Because the function represents the ability to find the value of my investment after any amount of time. So in this case, I will be doing it after 15 years, but what if they ask for something different? What if they ask for 15 years, and then 20 years, and then 30 years, right? So to write the equation, I am going to be leaving t in my problem. And so this is my first answer. This is the first part that they're asking for. Does that make sense? All right, so then the next thing to do is, as you say, t in this particular problem is 15 years, right? And so I'm going to be asked to find f of, and let's switch back to black here, f of 15. I'm finding the value after 15 years. And so that will give me 1,800 times 1.07 raised to the 15th power. Now, at this point, I'm going to kind of step out of taking the notes here, and I want to show you a tool that I use pretty often. You've seen it already, Desmos. I use Desmos a lot. But what I want to show you today is that Desmos is a pretty good calculator, especially for notes or homework. Obviously, you won't be able to use it on a test, because to use it, you have to have a phone or a computer, and I'm not going to be letting you use that on the test. But for taking notes or for doing homework, I think Desmos is a pretty powerful little tool. So, here we go. So as we found on our calculator when we typed all that in, our answer is $4,966.26. As this is a story problem, all story problems get labels. In this case, the label is the dollar symbol. And so that answers the second part of my problem, which was to find the value of the investment. Okay, to find the value of the investment after 15 years. And that is what we have found there. All right, see you after lunch. All right, so as I mentioned, we're going to skip number 2, and we are going to hop down to exponential decay. Does anyone have thoughts on what the equation for exponential decay might be? Yeah, why?
It might have a fraction.
Nope, not this time. That was a good thought, though. Yeah?
Is it f of t equals a 1 minus r?
There we go. The only difference between growth and decay is it's a minus and not a plus. All right, so here we go. Exponential decay is f of t is equal to a times 1 minus r raised to the power of t. And so everything pretty much stands for exactly the same thing. We have a, which still represents the initial amount. We have t, which still represents time. And we have r, which in this case is the decay rate. Instead of the growth rate, it's the decay rate. So A, again, is the initial amount. R is the decay rate, or the rate of decay. And then T is still time. I'd like to skip number 3 and hop down to number 4. And so we're going to talk about Mark and his brand new car. So he bought a brand new car in 2008 for $35,000. If the car depreciates in value approximately 8% each year, they want us to write an exponential function to model the situation. So again, we're going to be writing that equation, and then we're going to find the value of the car in 2015. So we have two different things that we're doing, much like we did in the last problem. So again, I like to start by defining some of the pieces. And so let's talk about A. A in this problem is? Yes? 35, not 3,500, 35,000. It's all good. 35,000 is A. And then R in this problem is, what do we got for R? Yeah. 0.08. So 0.08. Again, converting that 8% into its decimal form. So again, I like to write down what my equation is, the generic, before I go substituting things in. And so f of t is equal to a times 1 minus r raised to the power of t. So from here, we start plugging stuff in. So we have f of t equal to 35,000 times 1 minus 0.08 raised to the power of t. Since we're finding the function, we're going to leave t alone this time. And 1 minus 0.08 is what? Yes, Ms. Cooper? 0.92. So 35,000 times 92 hundredths raised to the power of t is the answer to what is the equation. All right, so now they're asking me to find the value of the car in 2015. So what is t in this particular problem? Ms. DeJesus? 7. But I don't see a 7 in my problem. Where's it come from? Very good. We're looking to find the amount of time that has passed from when it was bought in 2008 until the time they're asking for, which is 2015. And so in this particular problem, to find t, we have to take 2015 and subtract 2008, which does indeed give me 7. And so they are asking me to find f of 7, which is 35,000 times 0.92 raised to the 7th power. And so, again, I'm going to hop over to Desmos, and we have, according to our calculator, we have $19,524.63. And again, story problem, so it needs a label. And there's our answer. All right. So far, so good? Okay. So let's flip over to the back. One more type of problem to deal with. And that is compound interest. So, compound interest is what happens when a bank is calculating how much interest you owe it or it owes you. Usually it's how much you owe the bank, but there is a formula. Basically what happens with compound interest is paid more than one time per year. And so that's what it means to compound the interest, to pay it more than once per year. So, our formula is A equals P times 1 plus r divided by n raised to the n times t power. There's a lot going on in this one, but again, every letter has a value, and so let's start to plug in some of these. P is the principal, and in this case, the principal is or has another name. It can also be referred to as the initial amount. So the principal amount, or the initial amount, is what P stands for. R is still rate. This time it's not rate of growth or rate of decay, it's just rate. N is the tricky one. N is the number of times that something has been, or the interest has been compounded. The number of times interest has been compounded. And when we talk about how many times it's been compounded, it happens on a yearly basis. So when we talk about n being the number of times, we're talking about the number of times in 1 year. And then t still represents time. Excuse me, I apologize. T still represents the number of time. However, this time specifically, it's in years. So I don't know that we get any of these problems this time, but on occasion I've seen them give you problems where they tell you the time in months, which is no good because you need to turn it into years. But I don't think we have any of those today. All right, so let's play with this first one. We've got Laura, and she's invested or deposited $12,000 into an account that earns 8% interest. How much money will she have in 5 years if the interest is compounded quarterly? All right. So again, first thing to do, start defining all the different variables and what they represent. So the first thing we need to talk about is P. What is P? What does that one stand for? Yeah, what? 12,000. All right, 12,000. And then we have R, which is our rate. What's my rate? Say again? 0.08.
8. That's what they,
0.08. Very good. And then N is what? Yeah.
This is quarterly, so
4. Very good. Quarterly, like a quarter, there are 4 of them, right? So N is equal to 4, means they're going to compound the interest 4 times over the course of a year. And then last but not least, T in this case is 5. So again, we are plugging this in to our formula, which is right above you. And so we have A is equal to 12,000 times 1 plus 0.08 or 8 hundredths over 4 raised to the power of 4 times 5. All right, I'm going to hop over to my calculator and hit that. According to our calculator, that leaves me again with $17,831.60, and 37 cents. And that answers the question of how much money will she have if the interest is compounded quarterly at 8% for 5 years. Yep.
If you didn't have this, what order would you do it in? Would you be like 0.08 divided by 4 and then add the 1?
Mm-hmm.
And then multiply that by 20?
No, I would raise it to the 20th power,
Oh.
right? Not multiply by 20, but raise to the 20th power. So this is definitely calculator work. If you don't have a calculator, hopefully you have an electronic device that you can use for homework. But Come test time, you're going to want, quiz time, you're going to want a calculator. Okay? And your phone will not count as a calculator. So, your homework today is to finish the remaining problems on this worksheet. You have problem number 2, problem number 3, and then 6, 7, 8, and 9. And then I have one more worksheet for you. It's all about graphing these types of problems. So there'll be 8 problems on that one as well. So that's your homework. It's all due tomorrow. All right.